But we'll come to it after we are briefly going through that. Now, other thing in that is de Moivre's theorem. This is very powerful theorem. It says that if you have a complex number z and you raise it to the power n, then you can do it like this, or cosine theta, I sine theta raised to the power n, and that is equal to r raised to the power n cosine theta plus I sine theta raised to the power n, and that is equal to r raised to the power n cosine n theta plus I sine n theta. This is de Moivre's theorem, which can also be written as r raised to the power n e raised to the power I n theta, because this can be written as cosine n theta plus I sine n theta. So this is de Moivre's theorem. How, if what happens that if you raise a complex number to the power n, then you get this answer, that answer. These are two important results of the theorem. Okay, so this is how it is done. Now see, let's say we are asked that z is equal to 2 minus 3 iy. What is x? X is 2. What is y? It is 3i. What is y? It is 3. What is r? It is square of 2 plus square of y square root 4 plus 9 square root 13 square root. Says what is theta? Theta is tangent inverse y over x, which is tangent inverse y mean minus 3 divided by 2. Whatever answer you get, take tangent inverse of that, that will give you theta. Now look, a complex number can be plotted on a graph paper. If you say okay, we are going to plot this on a piece of paper, then look, this is x, this is y. How much is x? 2, 1, 2. How much is y? Minus 3, 1, 2, 3. This is minus 3. So your complex number will be somewhere here. So this line represents that complex number. This is making of angle this much with that. You measure it and you will get that. And how you can calculate it from this relation, this will give you length of the line will be 13 square root of 3. Okay? You can plot a complex number, let's say 4 plus 3i, 4 mean 4 here, 3i mean 3 there, and that is 4 plus 3i. Sometime we write it like that, 4, 3. This is an ordered pair. Ordered mean it is understood that first member of the pair is real and second is imaginary. Okay? That is imaginary. So that is how you plot it. If it was minus 4 plus 3i, then you have minus 4 here and then 3 up there. So that is minus 4 plus 3i. If you say, okay, plot minus 4 minus 3i, So minus 4 minus 3i will be there, that is that. If you say 4 minus 3i, that is 4, and minus 3i, that is there. So you see 4 plus 3i, minus 4 plus 3i, minus 4 minus 3i, and 4 minus 3i. 4 different complex numbers have been plotted. Okay, so that is how it is done. Now, when I said कि भाई a complex number is z is 2 minus 3i, x is this, y is that, I have calculated r, you can calculate theta here. Let's say theta is 300 degree. Assume theta is, because I don't have calculator to calculate it, suppose it is 300 degree, then I can write this complex number z as square root of 13, or right, cosine theta, cosine 300 plus I sine 300, or this is written as 13 square root e raised per I 300. This is understood, it is cosine 300 plus I sine 300. If somebody says raised to the power 2, I'll put that 2 there, and that will be square of this whole, and this will be square of this whole, and this will give me 13 square root whole square cosine of, you see de Moivre's theorem, n is there, so it is 2 into 300 plus I sine 2 into 300, and answer will be, this is 13, and that is cosine of 600 plus I sine 600, and this is another complex number which is square of the previous one. You can raise to the power 9 if you like. What happens? It will be 13 square root raised to the power 9 cosine of 9 into 300 plus I sine 9 into 300. Okay, so this is how this de Moivre's theorem is used. So what you should do, you should have some practice of this, and then next time we'll study how to find roots of a complex number. Okay, so I'll again give you some problem on this de Moivre's theorem, and you can practice it, and when you have any problem you can always talk to me on WhatsApp or just ring me. You will get the answer. Okay, now you can study solve problem 1.60 on page 29. Solve problem 1.60 page 629. This is on de Moivre's theorem. Okay, raised to the power 10 minus I plus square root of 3i raised to the power 10. That is the problem there, and you can also use okay, let me check it. Yes, unfortunately there is no problem, unsolved problem given on this topic. I'll give you one. Okay, so I am going to stop here. You study that. There's enough work which I have given to you, because now you will be busy in solving at least 4 problems there. This was the 5th one, and it will take time. You will come across with the problem. Talk to me, talk to your friends who are very hardworking, and they can solve it, because it is just the whatever you have done in your FSC course, it is not something new. The complicated things are coming in the future and we'll be paying more attention to that. Okay, thank you very much.